Swayam Prabha. Digital India. Educated India.
Welcome friends. Today I am going to discuss on GPS data preprocessing. This is the first part of the lesson. I will be talking on differencing. As you know, GPS observables are fraught with errors, and there are two types of GPS observables. One is code pseudo range PR, code pseudo range from satellite R to receiver R at any time t, and the phase pseudo range can be written like this, and this pseudo range R can be written with an observable equation like this, that is the geometric range of the receiver from the satellite R at time t, then the receiver clock error, then ionospheric error, tropospheric error, then satellite clock error, then our having that receiver hardware error, satellite hardware error, multipath error, and the random error. So similarly this is called the code pseudo range observable equation. Pseudo range observable equation. This is also we have learned in the last class. Similarly we can write the phase pseudo range equation like this, that geometric range plus integer ambiguity then receiver clock error, satellite clock error, ionospheric error, tropospheric error, receiver hardware error, satellite hardware error, multipath error, and random error. Now in these both the equation, though I have used similar symbol, but the actual amount of error that will be present in code pseudo range will be different from phase pseudo range. Now we process these observables equation to determine the position of the receiver. Now the quality of the position will depend upon what will be the quality of these observable equations. That means these observable equations should be free from all these errors. So to make these observable free from errors, we need to pre-process the GPS data, and to pre-process the GPS data we adopt many methods. One of the simplest and easiest and widely prevalent method is called transformation of GPS observables, in which we make use of these observables to arrive at a different type of observables where these errors is reduced or removed, and this one of the simplest method is called method of differencing. So today I will discuss on differencing. Today's class will be containing these three topics like single difference observables, double difference observables, triple difference observables. That means from these undifferenced observables we will go for a new type of observables, that is called single difference observable. By taking single difference of this observable, the double difference observables, by taking the double difference means difference of the single difference observables, and triple difference observables, which will be the observables taken as the difference of double difference observables. Now there are infinite ways how this can be carried out, but however we will do it in some particular way which has been researcher found that those are the best way to do to remove many of these errors or to minimize many of these errors. Now let me start with the single difference GPS observables. Now by the name itself we can understand that in case of single difference observable we will take the one time difference of these observables, but how will you take? There are three ways how it is to be done. One is that in first case we will take the difference of observable between two different stations taken from a single satellite and the same epoch of observation. So in that case, as we can see now, if the observables are from the same satellite and the observables are taken by the receivers at two different locations, so if we take the difference of that observables, then the errors that will be arising out from the space segment will be removed or minimized. So from two stations at the same epoch and at the same satellite. This is the first case. So when the observables are from the same satellites, so it is expected that the satellite clock error, then the satellite hardware error, these two will be identical in both the cases, and this will be minimized or removed. Now for other errors like your ionospheric error, tropospheric error, these two specifically ionospheric means atmospheric error will be minimized or removed depending upon the distance between the receiver. If the distance between the receivers are small, that means 1 kilometer or 2 kilometer, then it is expected that the signals will move to identical type of atmosphere. So the ionospheric error and tropospheric error is expected to be same, and when we will take the difference, then they will cancel out. Now this is a method generally we will use for relative positioning. Now let us consider the second type of single difference GPS observable. In this case we take observables from two satellites, observable coming from two satellites to one receiver, and at the same epoch. So the time of arrival of the signal is same and the receiver is same, so it is expected that the error that will arise due to receiver will be identical for each observable, and if we take the difference then those errors will be cancelling each other. Now if we look at to the pseudo range observable, that means this is the receiver error, receiver clock error, this is the receiver hardware error. These two errors will be removed and other errors, specifically the atmospheric errors will be minimized depending upon what is the distance between these satellite to satellites. So anyway, some minimization will be done. Now the next type, the third one, is that we do take the observation from at two different epoch, but the signal is coming to same receiver from same satellite. So as the signals are coming to same receiver and from the same satellites, it is expected that the errors arising out of space segment as well as receiver segment both are removed or minimized, and other error also will be minimized depending upon the time interval between two epoch, and this is a very important type of difference, so it is called delta range and it has many other uses, applications. Now with this we can say that signal difference, using signal difference observables we can reduce or minimize many of the errors that we get or that are present in GPS observables, and by relative positioning we go for this single differencing. Now next variety is that double difference. Actually in double difference, as you can see in this figure, in case of double difference we do take the difference of single difference observables. Now there are three ways how we can go the single difference. Similarly in case of double difference we have two out of three cases we can get two types of double difference, two categories, category 1 and category 2. Again under category 1 there may be two types. Now in category 1, actually category 1 we will consider signals or observables from two different satellites, and two receiver. Now under category 2 we consider, as you can see in the next figure, it is from one satellite and two epoch. So in both cases it will be two receiver, here one or same epoch. So we can see there are three variabilities, one is called satellite, another is called receiver, another is called epoch. So in under category 1 it is same satellite, two receiver, but under category 2 it is the epoch which will change, but it will be the two receiver and one satellite. So it is this is the two changes, that means either the satellite can be one or epoch can be one. In both cases we will take the signals from two different stations or two different receiver. Now under category 1, that means if the satellites are 2 satellites, 2 receiver, there may be again 2 different types. In one case it is that, as we can see in our previous one, is that difference from the different satellite at the same time, but from the 2 receiver, that is del So here we can see that the signal is coming from 2 satellites to a single receiver, a first receiver and single receiver B. That means it is the category of first difference. So this is the first difference, this was the thing. So we have to take the difference of this first difference is this one, and then this one. This is our receiver A and this is receiver B. So this one, and the difference of this will give us that this difference. Now another variety is that it is also written as pseudo range IJ ABT, but here the single, this will be different, PR ABI minus difference PB So that means what is this? This is the single difference variety, this one. So we have seen the single difference where we have taken the signal coming from a single satellite bound to receiver. So this is what is that, and when another satellite we are taking, in this case like this one, J satellites, from there we are taking it. So this is the case, this one. So we can take, apparently it looks like that both are same, but it is not the same, because here you will see the implications are different. And the third variety which we call the category 2, that is the pseudo range where so we are taking the difference in single difference observables So single satellite, 2 receiver, 2 epoch, single satellite, 2 receiver and 2 epoch. So that is the variety as we have seen it, this one. So this is taken, this is the first one, and then when I am taking for the same instant, this will be coming here. So this one, the difference of these two will provide us the double difference. Now double difference observables are the they remove both the most of the receiver as well as satellite errors. Double difference, because these atmospheric errors are not modeled, so there will be very the status of the atmospheric errors will be very unbalanced. Moreover, multipath error is also will not be taken care of in double difference. However, these double difference observables are the best kind of observables that we as a pre-processing, and generally we do go for double differencing for before we go for processing of the GPS signal. So, and the last one that we will consider as the triple difference. In case of triple difference, we will take the difference of double difference. So, if we take this del P R A B I J T1 and T2, that means we are taking two receiver, two satellites at two epoch of observation. So, two satellites, two receiver, two epoch of observation we will get for triple difference observable. So, like this. So, del P R A B I J T1 minus del P R A B I J T2. So, this is one of the variety, that means this is. So, I can take here this one, or I can take there this variety, or I can take there this variety. So, in that way we can, that means in the, if we take this one, then that means del P R I A B T1 T2 my difference del P R A B J T1 T2. So, there are three varieties of double difference. I can take this one for the T1 and this one for T2. I can take this one for this one. So, in that way ultimately we will end up with the same. So, only one output, only one type of triple difference. So, double difference you will get two types of double difference, whereas single difference we will get for three types of observables. So, triple difference observables are the observable where which we will be able to identify the presence of cycle slip. So, this is very important to as the pre-processing steps, as well as we can minimize many of the errors, and triple difference observables are processed to get the initial position of the receiver, and then from that position as the starting point we do process the data, double difference data as the, from the position from triple difference data as the input to the double difference processing, then we end up with a good solution. So, this is the process how we will end up with a better GPS position. With this I will conclude to this class, but however we can summarize to this class like this, that the GPS observables are fraught with errors. The quality of the GPS observable will depend upon how much errors can be minimized or removed, and that is we can do very easily, quite simplified way by taking the different difference methods. Now, in differencing we do take the similar type of observables. Now, fundamentally there may be infinite types, but basically as a practical point of view we have found that there are three fundamental ways how this differencing operation can be done. The first one is that first differencing, in which we do take the difference of observables from either from two satellites coming to the same receiver and at the same epoch, or the observables that is coming from a single satellite but at two receivers at the same epoch, or these observables we do take coming from same satellites at different epoch to the same receiver. So, in that way we have found that for different conditions the errors may be removed either for the space segment or for the receiver segment or both. Now, The next variety is the double difference, which is again it is the difference of the single difference observables, and there may be two categories. In the first category there will be two satellites observables coming from two satellites to two receivers, but we will consider observables at the same epoch of observation, and in that case we will be able to minimize the error from the receiver as well as satellites. In the second category we will be taking, we may take the observables from two receivers coming to from one satellite, but at two different epoch. In that case also, but we may also reduce the error due to receiver as well as satellite. However, these double difference errors also contains the error due to multipath and also the noise as well as the atmospheric errors causes some erratic behavior. So, we need to further process it, and the however second or double difference observables are the best observables which we should go for processing for precise positioning. After finding out the approximate position by making use of triple difference observables. Now triple difference observables are the difference of observables of double difference, since and in that case in triple difference observables provides us the cycle slips nicely. So the cycle slip error can be indicated and subsequently removed by triple difference observables. So with this I like to, and so triple difference is a very good thing to be done pre-processing before further processing is to be done. So with this I want to conclude today's class, and the next class we will be taking up again GPS pre-processing, but it is the second part. Thank you. See you again.